Good morning, friends. Welcome to this session. So, in this session, we will be discussing about the hydraulic circuits. Okay. So, mainly in this hydraulic circuit, we will be discussing about the traverse and feed circuit, then pressing circuit and riveting circuit. Syllabus already we know. Then course outcome for this session, that is for unit number 4. So course outcome is that to draw the circuit diagram of hydraulic system used in industrial applications. Then learning outcome, that is we have to identify the graphical symbols for the various types of hydraulic components. Then we have to explain the traverse and feed circuit. We will come to describe the hydraulic pressing circuit, then explain the riveting machine circuit. So first we will start with the traverse and feed circuit. So what is traverse and feed circuit? So already we have studied about the meter in and meter out circuit. So those are the speed control circuit. So traverse and feed circuit. So this is also one of the speed control method, wherein two different speeds are obtained during the forward stroke. So mainly in the forward stroke, that is in extension stroke, we will have the two different speed. So forward stroke, we call it as the working stroke of the cylinder. Okay, so the two different speeds, it comprises of, one is the fast speed, okay, that is called as the traverse speed, then which helps the piston to cover maximum length of cylinder within less time. So here in traverse and feed circuit, that is in forward stroke, we are having the two speeds. That is the first one, we call it as the fast speed, and that is called as the traverse speed. So it will cover the maximum length of the cylinder within the less time. So this is nothing but the fast approach of the working head towards the workspace. So here in the here the speed will be very high. As against this, the next part of the forward stroke will be the slower one. So first initially the stroke is fast, then this stroke will be slower one. So that we call it as the feed speed. Okay, that we call it as the feed speed. So which actually comprises of the engagement of working head with the workpiece. So here time required to travel the cylinder length, that is part of the cylinder length, is more. So here the time required will be high. So however the force generated is higher compared to the traverse part. So from this what we can come to know that traverse, it is the that is the fast speed, and that is this feed. Second part, it is the slower speed. So for the slower speed, the time travel will be higher, because here the pressure will increase. So that diagram we will see here. So this is having the many applications, like in pressing, we can use, okay, wherever we require the, and for the workpiece, to control the workpiece, like initially the speed will be very much high, and then after that what we want to have the slower approach. So slower approach in the sense, we have to apply the pressure to the workpiece. Okay, so here the uh, diagram consists of, that is tank. Here we know that what are the basic components of the traverse and feed circuit. Here it is the tank is there, okay, then filter is there. So I'm just writing this, already we have discussed so many times. Then P pump is there, okay, then pressure relief valve, PRV. So here 4 by 3 DCV is there, okay, and we have to show the ports P, A, B, T. Okay, P port, A port, B, and T port. So 4 ports are there, 4 by 3 direction control. And here we are having the flow control valve with the check valve. That is FCV is the flow control valve, and CV is the check valve. Okay. Then double acting cylinder is there. Double acting cylinder is there. And here what we are having that is the cam controlled roller cam that is roller operated 2 by 2 DCV is there. So this roller operated DCV, it will be controlled by this uh, cylinder rod. Okay. So then from the rod side of the cylinder, it is connected to the port B. Okay, so this is the circuit diagram of the traverse and feed circuit. So what you can observe here is that it is same as that of the meter in circuit. Meter in circuit also you are having this same part, but here what we are adding, we are adding this roller operated DCV, roller operated to DCV. Then it becomes the traverse and feed circuit. So here we will having the two speeds in the forward stroke. Okay, so that working we will see. So same diagram I am discussing here. So this diagram. Okay. So first I will discuss here about the forward position. How the diagram will that is the circuit will work in the forward position. That is for the spool position 1. So here this is the spool position 1. That means what? The flow will be from P to A, and return will be from B to T. Okay. So here what is that? That is the traverse rapid traverse. Okay. First oil from the pump will flow through the DCV1. So this is the DCV1. That is 4 by 3 DCV. It is DCV1. It will flow from P to A, and then through the DCV2. Okay. Then through the DCV2. So which will be P1 to 1. Okay. P1 to 1. So here what you can see, oil is flowing P to A. Okay. Then it is flow control. Oil will be also flowing through the flow control, and also the oil will be flowing through this DCV2, that is P1 to A1. Okay. So then oil goes to the cylinder. Okay. Then oil will go to the cylinder. Okay. Then and forward stroke will take place. So forward stroke means what? This piston will move forward. So this is the part covered by the working head from O dash to P dash. Okay. So here one thing you know that so here this cam will be there here, cam that is the and roller is there. Okay. So when O dash to P dash, okay, so initially this roller position it will be here. Okay, it will be at the O dash roller position. So as the cylinder rod it moves in the forward direction, so this roller will start moving in the opposite direction. So it will move in the opposite direction. So that means its travel is from O dash to P dash. Okay. So O dash to P dash, what will happen? This piston is moving in very fast direction. Okay, that is the traverse approach. That is the traverse approach. Okay. So here what happens? That is O dash to P dash. Okay, that is roller operated 2 by 2 DCV moves from O dash to P dash. Okay, so it is moving from this roller operated DCV, it is moving from O dash to P dash. So working head engages with the roller of DCV2 at point P dash. So this spool position changes from 1 to 2 at Q dash. So you can see that when the roller will move from P dash to Q dash, so that time what will happen? There is the engage of this roller. Okay, there is the engage of this roller. So that what will happen? So here the position will change from that is so this is the first position. Okay, so then it will change to the second position. So second position here it is closed one. Okay, so it will change to the closed position. Okay, so now what will happen? Now oil flows through flow control. Okay, so whose opening determines the speed of the further stroke. So since this now this initially what was happened when the fast approach was there, that is the rapid traverse approach was there, that time the flow was oil was flowing from P1 to A1. Okay, and this roller was moving, so it was traveling from O dash to P dash. Okay, then after P dash to Q dash, what will happen? The roller due to the action on the roller, the position changes. So that time this 2 by 2 DCV wall will get closed. So if 2 by 2 DCV wall get closed, so that time the oil flow will be only through this flow control wall, and depending upon the flow control wall opening, that is the flow rate, whatever the flow rate is there, that will be passed through this cylinder. So okay, so this speed is called the feed speed, so which is less than the traverse speed. So working head travels from Q dash to R. So working head travels from, so as this cylinder piston rod will be moving, so this this roller will be moving from Q dash to R dash. So in both the parts, the used oil from rod side flows back to the tank through the DCV1, that is B to T. So once the stroke is completed, when this roller it reaches to the R dash, okay, that is the completion of the extension stroke. So that time oil from the rod side, okay, so uh, come it will come to the port B. Okay, from port B it will go to the tank port. Okay, so in this way, that is the in the forward stroke, what is happening there, we are having the two speeds, that is the rapid traverse, that is fast speed, and the slow speed. Okay, so slow speed, that is we can control by using the flow control wall. We can control by using the flow control wall. Okay, and one more thing is that in the slow speed, the pressure will be high. Pressure will be high. So like initially, what we will do, we want to one workpiece is there. Okay, we have to drill that workpiece. So drill will come very fastly. Okay, then after that, what we have to do, we have to do the hole to that workpiece. So that hole will be done in the slow speed. Okay, so in this way we can control. Then in return position, what will happen? So return position, I have to change, that is 1 to second position. So I have to change from 1 to 2. Okay, 1 to 2. So in the return position, what will happen? So since this that is the rod has initially extended, so it has to come to its original position. Okay, so rod will be coming to its original position. That time what will happen? That time this roller was at the R dash. Okay, so that we will see the oil from the pump flows through DCV1. So what will happen? The oil from pump, it will flow through the DCV1, that is P to B, DC1 P to B. Okay, and then to the rod side. Okay, the oil from piston side flows through check wall and through DC1, that is A to T, and to the tank. So also what we can say, after Q dash position of the working head, that is from P dash to O dash, the oil from piston side will be flowing through DCV2, that is A1 to P1, and through check wall before going to DCV1. Okay, so we will see how the flow is going. So the flow for the return position. For the return position, the flow will be from P to B. Okay, P to B. P to B means what? The oil will be flowing. Okay, it will be flowing to the rod side. Okay, then this piston initially it was extended, so this piston will be moving to its backward. Okay, to its original position, so that oil from the piston side, it will be going through this flow control wall. Okay, then also the check wall, both it will be going, and it will be going to where? It will be coming to port A. Okay, from port A it will go to tank port. Okay, tank port. So in this way, in this position, what was happening? Uh, so the roller was here. Roller was at the R dash. Okay, then so since the this rod is coming backward, so roller will be moving forward. Okay, roller जब Q dash पे आएगा तो क्या होगा? So it will engage. Roller will actuate. So actuate वजह से क्या होगा? Now it was at the close position. So close position था, तो क्या हो जाएगा? It will get open. Open means what? A1 to P1 रहेगा. ठीक है? So that time what will happen? When the oil is that is फिर से जब retraction होगा, मतलब that is rod जो है it is coming to the backward side and roller it is going to the forward position. So that time what will happen? Oil will be flowing through this check valve, then flow control valve, then also the oil will be flowing through this A1 to P1. Okay, A1 to P1, and also it will be collecting here. So that, and from here port A it will be going to the tank. So what you can observe that in the retraction, the oil will be flowing through flow control valve, through check valve, and also through this 2x2 direction control, so that the retraction speed will be very much higher in case of this traverse and feed circuit. Okay, so this was about the traverse and feed circuit. So next we will discuss about the hydraulic press circuit. So hydraulic press circuit, what is hydraulic press circuit? So here this is the basically used in the forging or drawing or pressing. So wherever the high pressures are required, like in forging we require high pressure, then in drawing, then in pressing. So here we can use this hydraulic press circuit. So every hydraulic press is characterized by the following. That is, it gives the large amount of force. So here the force is very much high. Then quantity of the fluid is also very large. The size of the lines, cylinders, etc., they are also large. So what are the actuators like cylinders which we are using in this hydraulic press circuit? They are also very large. So due to the above working, pressure range of the hydraulic pressure is quite high. So normally here in the hydraulic press circuit, the pressure will be very much high. So the circuit diagram we will see. What is the circuit diagram of hydraulic press circuit? So again here the basic components are, that is tank, filter, pump, then pressure relief valve. So these combinedly we can use in the power pack unit. Okay, so here you can see one check valve. Check valve is there. Okay, so this is check valve 1. Then here we are having one more check valve. This is check valve 2. Then we are having 4x3 DCV, which is closed, spring centered and manually operated. Okay, center position is closed. So that is the from port A, that is here we are having again 4 ports, P, A, B and T. So port A it is connected to the piston side. Okay, port A is connected to the piston side. Okay, then port B is connected to the sequence valve. Sequence valve, we are using one sequence valve here. Okay, so sequence valve inlet, it is connected to the rod side, and sequence valve outlet, it is connected to the check valve 2. Okay, so this is the flow direction. So yeah, this is the flow direction, and for here check valve 1, this will be the flow direction. Okay, so that means left side the flow will happen, and here the load will be there. Okay, so here the cylinder is the vertical cylinder, double acting vertical cylinder. So this is the circuit diagram of the hydraulic press circuit. So we will see how what happens in the forward stroke, then what happens in the return stroke. Forward stroke means what? I have to change from close center to first first position. So that is P to N, B to T. That is the port position will be P to A and B to E. So here what will be happening? Pump oil from the pump, it is going to the piston side. So oil from the pump is going to the piston side for pressing. Okay, normally you can see here this load is there, so you can imagine here the workpiece is there, so that I have to press that workpiece. So here the pressure required is high. Then oil from the rod side is regenerated. Okay, oil from the rod side is regenerated. You can see that oil from the rod side, it is coming here. Okay, it is coming here, so that again it will be going to the P2A, so that oil is regenerated. Okay, if the pressure further exceeds the pilot line taken from the main line, that opens the sequence valve to allow flow to pass to tank through the DCA. Okay, so this we will discuss how it will work. Then in the return stroke, what is happening? Return stroke, the this one port positions are P to B and A to T. So oil will be flowing from P to B, that is pump to rod side. Pump to rod side, it will be going through check valve 2. Okay, so oil will flow through the check valve 2, then it will come to the rod side, then the piston will be lifted upward. Okay, then oil from the piston side will go to the tank. Okay, so this circuit I have drawn in this Festo, that is fluid sim software. Okay, so in this way you can see here. So whatever this tank, filter, pump, and pressure relief wall are there, so that we call it as the power pack unit. Okay, so here that is the pump unit. So as check valve 1 is there, then check valve 2 is there. Then here we can see. So this is in the closed center. What will be happen? What will be happen? Oil from the pump will go. So P port is blocked. Okay, that means what? Or the pressure relief valve will get open. So you can see here. So this is the open position of the pressure relief valve. Okay, so oil will flow to the tank. And here, whatever it will be double acting cylinder sequence, they will be in their original position. Then when I change the position, okay, when I change the position, so there will be the extension. Okay, so here you can see when I operate the lever, so flow will be from P to A. You can see P to A, that is the oil will be flowing here. So you can see that dashed line, so that is the working position. Okay, so then it will come to the piston side of the double acting cylinder. Okay, so then piston will move downward. So here the load will be there. Whatever the load, it is 10 kilonewton and all, the load will be there. So it will be coming down. That pressing will be done. Okay, then oil from the rod side, what it will do? It will be going to check valve 1. So this check valve you can see here. So this ball gets open. Okay, so as I said, the oil is regenerated. Okay, oil is regenerated. So actually its connection will be here. So oil will be regenerated. Okay. So here the oil cannot go through this check valve 2 because here it is in the blocked position. Okay. So next you can see here, when this oil, that is when this is for the when fully extended position. This is for the when the oil is fully extended position. So in the fully extended position, what will happen? If further the pressure increases, that time this sequence valve will get open. So sequence valve will get open, and sequence valve will get open. So that time oil from the rod side will go through the sequence valve. Okay, and also the oil will be flowing through this check valve 1. Okay, so then in the retraction, what will happen? Oil will be flowing. Oil will be flowing. Okay, in from P to B. Okay, then from P to B it will be going to this check wall 2. From the check wall 2 it will be flowing through this rod side. Then oil will be flowing from piston side to port A. Okay, from port A the oil will be flowing to the tank. Okay, so in this way, and this shows about the complete extension. So complete extension, what you can see, the oil is that is oil is flowing through this check wall 2. Okay, so what we can see here in this circuit is that, so in the first position check wall 1 is operating. Okay, and second position, that is full position second, so check wall 2 will be operating. So mainly this is used to control the oil flow in the circuit, and whatever the pressing is there, it has to be done smoothly. And sequence valve will come in action when the pressure is increased. When the pressure is increased. Okay, so next circuit is the riveting machine circuit. So here what happens? So for the riveting machine, the pressure is very high. So whatever the pressure required is there, it is high for the riveting operation. So for that case, what we are doing, the intensifier is used to boost the pressure. So we are using here the pressure intensifier. So normally pressure intensifier, what it does, it boosts the pressure. That is, it will increase the pressure. So there are here three types of operation. That is rapid traverse operation, that is advanced. So here what will happen, the rivet head of the machine should approach as fast as possible. Okay, so that is rivet head will approach very fast to the job. Then second is the actual working, that is riveting, that is heavy feed. So here what is happening, intensifier pressure is applied on the riveted head so that a rivet can join two worksheets together. So this cycle requires the higher pressure. Then third operation is the withdrawal of the rivet head. So after completion of the riveting, the head should be withdrawn as rapidly as possible. Okay. So here again, it is similar to that. You can compare with the traverse and feed circuit. So here initially that we want the advance for the riveting. That is whatever the rivet head is there, it has to approach very fast to the job. Then second is that heavy feed is required. Heavy feed means what? That is higher pressure is required so that we can join that worksheets. Okay, so to join that worksheet, whatever the higher pressure required is there, that we can supply from the intensifier pressure. Okay, then after the riveting is done, then there should be the withdrawal of the rivet, so as rapidly as possible. So these two comes under this extension stroke, that is the forward stroke, and this withdrawal of rivet will come under the retraction stroke. So this is the diagram of the riveting machine circuit. So this is the common, that is pressure relief valve, tank filter, and pump. So this we call it as the power pack unit. Then we are having the 4x3 DCV, 4x3 DCV. Okay, that is close center. Then here we are having the sequence valve. Then one pilot operated check valve. Okay, then intensifier is there. So the port A is connected to the sequence valve. Then port A only it is connected to the check valve. That is, and sequence valve is connected to the intensifier. Okay, from here the connection is to the piston side. Then from the rod side, uh, rod side, the oil flow that is connected to the port B and to the tank. So that is pilot line of the check valve. It is a pilot operated check valve. Pilot line, it is connected to this rod side line. Okay. So forward stroke, it is the riveting, and return stroke means what? We will take the rivet back. So this we can see through this circuit diagram. So again, this diagram we are so I have done in this Festo software. So this is for the center position. Center position, what you can see, since the all the ports are closed, so oil will flow to the pressure relief valve and to the tank. Okay. Then in the second position, what you can observe, so that is when this cylinder is extending, that is in the forward stroke. Initially for the rivet head, when it will move very fast. Okay, so that time oil will be flowing through this check valve, pilot operated check valve. Okay. Then oil will be flowing to this piston side. Then from rod side, oil will be flowing to this port B, and to the tank. So you can see here, the oil is flowing through this pilot operated check valve. Okay. Then oil from the rod side, it is coming to the tank. So this is while in the extension. That is the first part of the riveting. Okay. Then second part, what in the forward stroke. Okay, so oil will be flowing through this check valve also. But since when the extension is reached, so there we have to do the riveting. So that is, we have to join the workpieces. So that time the pressure has to be increased. So what will happen then? That time the oil will be flowing through this sequence valve. Okay, so then from sequence valve it will go to the pressure intensifier. So pressure intensifier already it will increase the pressure. Okay, so then oil will go to that is piston side. Then the high pressure is applied so that the riveting will be done. Okay, riveting will be done. After riveting, so here the oil is there, it will come to the rod side, that is oil, it will be returned to the tank. Okay, so in this way riveting will be happening. So here that is fast approach, then heavy feed. Heavy feed is done by using this pressure intensifier. Then what we have to do, we have to next stroke is, that is in retraction, we have to unrivet, that is we have to get the rivet to its original position. So that time what will happen, the flow from the pump, it will go to the P port, then to the B port. From the B port it will go to the where, rod side. Okay, from the rod side, then the piston will move backward. Okay, it will be very fastly it will moving. So here you can see here as this is the closed position, but we are having the pressure, pilot operated pressure. So pilot line will be acting at the inlet. So due to this, what will happen, this ball will get open and oil can flow and come to port A and to the tank. Okay, so in this way the riveting circuit will work. So this we have seen through this three uh, stages, that is rapid traverse, that is advanced, that is high speed, then heavy speed. Okay, the heavy speed is the slow speed, then withdrawal of the rivet head. Okay, so in this today's session we have discussed about the traverse and feed circuit, then riveting machine circuit, and about the hydraulic press circuit. So thank you very much.